In this video, we're going to be talking about Newton's second law of motion. And let's start with a surface. Let's say, for example, we had an object that is just lying on a surface. And this is just a block of mass. If this object was not moving anywhere, we can just call this object A. If this object was not moving anywhere, there would be a force that is pushing down on the object. Actually, the force would be there whether it's moving or it's not moving. However, I just want to focus on two forces here. So there is a force that is acting on this object that's just sitting down. And this is a downward pushing force. If you were to take a very heavy object and you were to place it on your lap, you're going to feel some sort of heaviness. And that is because the object wants to go downwards. If we were to take this object and we just put it into outer space or into the air, there will be a force that's pushing down on it. And it's going to keep on falling until it hits the ground. And that force happens to be the force of gravity, F of g. However, this surface also happens to be applying a force that is facing upward on this particular object. And this force here balances out in such a way that it keeps this object not moving anywhere. If this object is not going anywhere, it just so happens that the force of gravity is equals to this upward facing force here. And this is the normal force. We just call that F of n. And we can say that this normal force is equal to the gravitational force, and the normal force is facing upwards while the gravitational force is facing downwards. So we can put this on a number line on a Cartesian plane to say that if this is our Cartesian plane, all forces that are facing downwards happen to be negative, while all forces that are facing upwards happen to be positive. So in this particular case, we can say that our normal force is the positive one and the force of gravity is negative. However, if we solve the equation here to say Fg minus, I can actually take this to the other side and just say the normal force minus the gravitational force balance out equal to 0. So this is all that is happening here. There is just a force of gravity that's facing downwards and a normal force that is facing upwards. What if this object was to start accelerating? If this object was to start accelerating, if we had another object here, and this object just happens to be moving to the right at some speed, there is a force that is causing this object to move to the right, right? And we call that force the applied force, F of A. So this object still has that gravitational force, Fg, and it still has that upward force, the normal force, and now it has this force applied. Now there is another force that has a tendency to oppose an object in motion. As this object is moving to the right, as this object is moving to this direction to the right, there's another force that wants to stop it and bring it to the left, right? As it's moving to the right, there's another force that wants to stop this object, right? And you can think about if you're in a car and you're pressing on the accelerator, the car continuously moves forward. You're applying a force continuously. But when you stop applying a force and you just leave the car, eventually it's going to come to a stop. That's because there's a force of friction that is pulling it backwards. And these are the forces that we concern ourselves with on a particular diagram that is resting on a surface. And for this particular case, this object is accelerating, it's moving in a particular direction. If an object is moving in a particular direction, it just means that there is a force that is being applied that is causing it to move. Because if you just take an object and you rest it on a surface, it's not going to move on its own until you apply some force to a particular direction. Now, I want you to note with these two forces here, friction and applied force, the direction of the applied force will always be positive, whereas the direction of friction will always be negative. And this, if this particular object was moving to the left, then that means friction was going to be negative. That means the left was going to be positive and the right was going to be negative. So that's why I didn't include it in this particular direction, but in this particular diagram. But I could just add that to say that in this particular diagram, we have an applied force that's facing towards the right, and we have another force of friction that's facing towards the left. Now, this also happens to be called a free body diagram, where it's called a free body diagram because there is no body here. Here there is a body diagram, but here there's a free body diagram. We just represent it by a dot. and then we show the direction of the forces that are acting on this particular object. So I just wanted to give a basic introduction of Newton's second law of motion, and we gave definitions to say the force of gravity is a downward facing force that pulls object towards the center of the earth. The normal force is the force that the surface applies onto the object, and when the object is resting on the surface, it means that the force is zero. Then we spoke about the force of friction that opposes a body in motion, and we have an applied force that moves in the direction where the object is moving toward.